Hello dear friends, let us continue the today's class with the new title Interference of Light. Already in our wave optics chapter we have seen the reflection of light and the refraction of light concept in detail. This reflection and refraction of light again we have seen in detail in your array optics and optical instrument chapter also, and the proof of the law of reflection and the law of refraction we have seen in our present chapter. Today's class we are going to start with the new property of light, that is called the interference of light. The question will come in your mind, what is the exact meaning of interference of light? So here interfere, what is the meaning of interfere? The two waves which are representing light, because in this chapter we are representing the light in the form of wave, hence the title of the chapter is wave optics here. So how many waves we have? Two waves, two light waves we have, and when the two light waves will meet at one common point, at that point the one light is going to interfere in the path of other light. So it is called the interference of light. So to produce the interference of light, minimum we require two sources. Maximum it can be anything, but minimum two waves of light must meet at one common point to produce the interference of light here. So when the light is going to mix at one given point, at that point we have to apply one principle, and that principle is called a superposition principle. I have written on the board. What do you mean by superposition principle? We have seen that already in your PUC first year. So whenever the two waves will meet at a given point, then the resultant displacement of that point is the vector sum of the two vectors meeting at that point. Means what you have to do here, at the point of intersection of the two waves, whatever the resultant displacement if you want to calculate, that resultant displacement is equal to the vector sum of the displacement of each wave produced at that point, right? So it is the point we have to explain here. So superposition principle, this statement I know you can't understand properly, you might have forgotten because you have studied in PUC first year. So to overcome that difficulty I have drawn the diagram here. We can see what these diagrams are suggesting. So here we have got one wave. For your information, this yellow color is crest, red color is trough, crest, trough, crest, trough, like this your wave is moving. We know this is one complete wave, one yellow portion, one red portion, this is complete wave, and this length is called as what? Wavelength, right? Wavelength is lambda here. Now this angle is 0, this is 90, this is 180 degree, and this is 270, and lastly it is what here? 360 degree, and 360 degree angle is nothing but 2 pi radian. So what I can write here, the one wave is completed means what is wavelength covered? Lambda, and what is the angle covered? It is 2 pi. Okay, so this thing you keep in your mind because I need this concept in this today's class here. Wavelength of lambda is equal to angle of 2 pi radian. So one wave is finished means what is the length covered by the wave? Wavelength lambda, and what is the angle described by the wave? It is equal to 2 pi. So lambda is equal to 2 pi relation we have to study here. Now I have drawn the two diagrams here. So you can see there are clearly two waves we have. Purposely I made use of the different colors. See here, this is one wave, small, this is a big wave, it is moving here. Here this is the big wave moving, and here this is small wave moving. So are they interfering each other? They are going to mix each other, and because of this interference of light, the intensity of the light energy will go on redistributing. So what is the interference of light definition? It is a phenomenon of the distribution of light energy due to superposition of two or more waves meeting at one common point. So how this light is going to distribute, we'll see here. So in the first diagram, if I talk about this point here, is it at this point crest of both the waves are falling here? Crest of both the waves are falling. So crest means positive, again positive, so resultant wave will be again having more amplitude, right? So for your reference, we know this is called the amplitude of the wave. This is amplitude with plus, this is amplitude with minus here. Okay, so here both these are plus plus, so this is your resultant wave here, right? This resultant wave is having more amplitude here, right? This resultant wave, we have the more amplitude, and we know the intensity of the wave is directly proportional to square of the amplitude. So what is the amplitude of this yellow wave? It is more. So what is the intensity of the resultant wave? It is also more, and this interference is called here constructive interference. What is called constructive interference? Because crest of one wave is going to fall on the crest of other wave. In this case, what is happening here? This is positive, okay, and this is negative here. So one amplitude is plus, another is minus. So plus minus means, example, you see this is equal to plus 2 and this is equal to minus 1. So plus 2 mixing with minus 1, plus 2 minus 1 means plus 1, nothing but 2 minus 1 only. So your next wave will have the amplitude of 1 and you will have this wave here. So what is the amplitude of the resultant wave? Yellow color. Is it decreases now? And this we know, again the intensity of the wave is directly proportional to square of the amplitude, and here we will have the destructive interference. Why destructive interference? Because the intensity of the resultant light goes on decreasing. So can I make one statement like this? Whenever you will have the constructive interference, the intensity of the resultant wave will increase, and whenever you will have the destructive interference, the intensity of the resultant wave will decrease. So whenever you will have the intensity high, you will get the brightness, and whenever you will have the intensity of light less, you will get darkness. So whatever the brightness you are getting, that is the constructive interference. For constructive interference, you are going to get the brightness, and for destructive interference, you are going to get the darkness here. Okay, so these the points you have to study. One point I will tell you important in your CET exam: the intensity of light in constructive interference is large, and it is 4 times of incident wave intensity. Means incident light, if it is having the intensity of I naught, then after constructive interference, this intensity of incident light is multiplied by 4. The question will come in your mind, why? And for that I have to go for the theory of interference. What is the theory of interference? It is suggesting me. It is suggesting that in constructive interference, the intensity of light is going to have the maximum, and that maximum intensity of light is equal to 4 times of the incident intensity of light. So whatever my input is there, it is multiplied by 4. So light intensity is less now, but it is multiplied by 4. So for constructive interference, you are going to get the brightness here. But for destructive interference, the resultant wave intensity is equal to 0, because this also we will prove. Because we are going to have the darkness, means what is the intensity of the resultant wave is going to be equal to 0 only. These two are the questions will be there in your mind. For that I am going to explain this theory of interference. I hope you have understood, right? And to study this interference of light, minimum we require the 2 sources of light. What type of sources I have considered? Coherent sources. What is the meaning of coherent sources? The 2 sources of light are said to be coherent if they are emitting the light of same wavelength and with the same phase difference. So I have written here S1, S2. I represented them by different colors, but the waves emitting out from S1 and the wave emitting out from the S2, they have got the same wavelength here. They have got the same wavelength, right? So on the board I will draw the 3 diagrams here, and then I will go for the theory of this interference, right? Just see, very interesting concept. If you understood, then only it is helpful to you, otherwise you will have the confusion in this chapter. So I have got the 2 sources, S1, and next source of light I will mark as S2. Okay, now S1P is equal to S2P means clearly the point P must be somewhere here. This is a point P here. So if I join S1P and here if I join S2P, then clearly S1P is equal to S2P. So here I will make the 2 partitions here. I am going to make the 2 partitions. So see here now, the wave coming out from S1 will reach the point P like this here. Okay, now the wave coming out from S2 will reach the point P like this here. Now my question is, here you will have the constructive interference or destructive interference. For your information, both these waves have got the same amplitude here, A and A. Small a is amplitude of the two waves, maybe first wave or second wave. Now at point P, you will have the constructive interference or destructive. For constructive interference, what is the condition I told you? The crest of one wave must fall on the crest of other wave. So is it at this point P, or next condition here, the trough of one wave is falling on the trough of other. Crest or trough, you will have the constructive interference. So is it at point P, trough and trough are falling each other? So this is the constructive interference. This is crest, trough, crest. So at the point of intersection, trough of one wave is going to fall on the trough of other wave. Nothing but this case here, trough falling here. So it is taken as what? Constructive interference, right? So this is the first case, is the representation of what type of interference here? It is the constructive interference. I have written in short here. And for this interference, we know we have to prove that the intensity of the resultant light is 4 times of I naught. This I have to represent here. I can represent here. I can prove this. Very easy for me to prove this. It is not that much tough. So see here now. So these two I will take afterwards. Right now I am dealing with the S1P is equal to S2P, right? So this I will calculate afterwards here. So initially, otherwise I will draw the diagram first here. Now this is S1 and S2. For what type of interference I am telling here? It is for the constructive type interference, where the intensity of the resultant wave is equal to 4 times of I naught. Now next point here, this is S1, right? This is S1. Now next I have to mark as S2. So see here now, this is I am going to mark as next point here. This is S2. Okay. Now S1Q is less than S2Q. So your Q point must be somewhere here, so that I can say this S1Q is less than S2Q. Okay. Now here see, I am going to make the two partitions here. Here also you will have the two partitions, but one partition is extra. Why extra here? Because clearly what I have shown here, S1 S2 distance is less. Here S1 S2 distance I have almost doubled here. I have doubled. Now what will happen? Just see here. This first wave will reach here at this point Q. Okay. Now the next wave coming from S2 will come like this here. Right? This is coming like this. Now you tell me what type of interference it is, constructive or destructive? No doubt it is again constructive interference. Why? Trough is falling at trough. Previous crest, trough, crest, and this portion is extra. We have this portion extra. So this is taken as lambda. So what is the path difference here? Is it this extra wave we have here? We have this extra wave. So can I write here S2Q minus S1Q is equal to, here I will write here, this is called delta, and delta is called a path difference. What delta is called here? Path difference. So this implies this path difference is equal to S2Q. What is S2Q? Is it equal to 1, 2 and 3? Is it 3 lambda? Minus S1Q is equal to 1 and 2. This is 2 lambda. So this implies the path difference is equal to 3 lambda minus 2 lambda is equal to lambda here. Okay. This side path difference is what here? What is the path difference? Delta is equal to S2P minus S1P. What is S2P here? S2P is 2 lambda. What is S1P here? It is also equal to 2 lambda. So what this you will give now? You will get like this, delta is equal to 0. Is it these two conditions are there to have the constructive interference? Why this is also constructive interference? Because the trough is falling at trough, and same thing is going to repeat here. So it is both these are the examples of the constructive interference. I will write for your reference here. S1P is equal to S2P and S1Q is less than S2Q. All these are the examples of the constructive interference. I will write like this. These are the examples of constructive interference. And for this first one, what is the path difference we have proved? Delta equal to 0. And for the second one, what is the path difference we have proved? Delta is equal to lambda. So what I can say, the two waves are said to interfere constructively, right? Here I am going to write, the two waves are said to interfere constructively if the path difference between the two waves, if the path difference between the two waves is equal to delta is equal to 0, comma, lambda, comma, 2 lambda, comma, 3 lambda, so on up to. Alright, so this is the condition for the constructive interference. Why this is constructive interference? Because path difference is 0. Again, why the path difference is, what is the path difference value here? Lambda. Is it why lambda is path difference? Because this wave is extra here. And again for this, is it these two diagrams are same here? Provided this path difference is not considered. So whenever you will have the path difference of lambda, again you are going to have the two waves and two waves only. I mean, this is also a condition for the constructive interference. So we can write this constructive interference like this. The two waves are said to interfere constructively if the path difference between the two waves is equal to integral multiple of lambda, where n is equal to 0, 1, 2, 3, 4, so on up to. Okay, so what I told here, this condition can be asked for 2 marks. Write the condition to have the constructive interference. Then what you should write here, the two waves are said to interfere constructively if the path difference between the two waves is equal to the integral multiple of the wavelength. Integral multiple of the wavelength, nothing but delta is equal to n lambda. You keep any value of n, n equal to 0, first diagram, constructive interference, n equal to 1, second diagram. Again you have the constructive interference, you keep n equal to 2, means instead of 1 here, even if you have the 2 waves extra, here again crest is falling, trough, crest, trough. So either you should have the path difference 0 or path difference between the two waves is equal to lambda, 2 lambda, 3 lambda, so on up to, you are going to have the constructive interference. Okay, now I will write the one more diagram for destructive interference. Just see now. So the constructive interference is completed. Now we will have the next concept here. And what is the intensity of light for this constructive interference? The resultant wave intensity is 4 times of I naught. This only we have to prove. Here also I wrote the same thing here, so that we have to prove here. Now S1 and S2, right? Now this is the path difference. This is the distance for two waves, this is the distance for one wave, and this small would be the distance for half wave. So just here now I am going to draw this diagram. This is S1 and the next distance I am going to represent here S2. Now S1R is greater than S2R. So S2R is less here, so your point is somewhere here. This is the point R. So clearly S1R is greater than S2R. Okay. Now here I am going to make the two partitions, 1, 2. Here also 1, 2, and clearly see here now 1, 2. Here also 1 and this is 2. Right. So two equal partitions I have to make here. Now this portion is extra here. This portion is extra. So just see how I will draw the wave. See here now. Very interesting concept here. In the live class it is very interesting to teach in the classroom, but I am trying my best to represent in this YouTube class. But just see here, you have to be very careful while observing this diagram. Now this is the path difference of how much here? Is it half wave is extra? So half wave means what? Lambda by 2. Full wave means lambda and half wave means lambda by 2. Now this diagram is for constructive interference or destructive. You observe at point R. Is it crest of one wave falling on trough of other wave? Plus and minus are coinciding at this point. So plus minus, this is equal to what? 0. So what is the intensity of light? 0 here. Why? Because the crest is falling at trough. Same thing happening here. Crest is falling at trough. crest, trough like this. So you are going to have what type of interference here? We are going to have the destructive interference, and for destructive interference this we are going to have the darkness here. And with what this path difference delta is equal to, it is S1R minus S2R. So what is S1R? S1 is 1, 2 and half. So is it 2.5 lambda? Addis lambda will call, Addis wavelength height 1, 1, 2 and half. And what is this S2R? 1 and 2, 2 here. So it is 2 lambda. So difference is equal to 0.5 lambda, and 0.5 lambda means half lambda. Okay, half lambda. So whenever the path difference between the two waves is going to be equal to, I am going to write here same concept here. Whenever the path difference delta between the two waves is going to be equal to lambda by 2, comma, it is 1 times of lambda by 2. Next is 3 lambda by 2, 5 lambda by 2, so on up to, you will have the destructive interference. How? If you ask, I proved first, and remaining we can have by your as your homework now. So if the full wave is extra 1, 2, 3, 4 anything, you will have the constructive interference. But if half wave is extra, half, 1 and half, 2 and half, 3 and half, so in that case you are going to have the destructive interference. It is a common sense that if half waves are 2 and half waves are there, means 1, 2 and half, and here trough will come, and trough is falling at crest. Maybe 3 and half here, or 1 and half. 1 and half means what? One wave is already formed, and next is half here. So 1 and half. So next is trough is falling here on what? Crest. So trough is falling at crest to get the destructive interference, right? So what are these here? The two waves are said to interfere constructively if path difference between the two waves is equal to 2n plus 1 times of lambda by 2, where this n value is equal to 0, 1, 2, 3, 4, so on up to. So here what is happening here? Keep the value of n equal to 0 in this expression. So 2 into 0, 0, 0 plus 1, 1. So lambda by 2 is first one. Now keep n value equal to 1. So 2 into 1 is what? 2. 2 plus 1 is what? 3 lambda by 2. This is also correct. Keep n value is equal to 2. 2 into 2, 2, 4. 4 plus 1, 5 lambda by 2. So we have got, this is the condition for the destructive interference. This is the condition for constructive interference. This is destructive interference. This is for constructive here. So we can write this for 2 marks here. These are very important here. See here, these two conditions, they are very important. How I can write here? The two waves, listen carefully, the two waves are said to interfere constructively if the path difference between the two waves is equal to integral multiple of wavelength. Done. It is for constructive interference. For destructive interference, this condition, the two waves are said to interfere destructively if the path difference between the two waves is equal to 2n plus 1 times of the lambda by 2. Right? The two waves are said to interfere destructively if the path difference between the two waves is equal to odd multiple of lambda by 2. Why it is odd multiple? Because you keep any value of n here, 0, 1, 2, 3, 4, so on up to, this bracket terms is going to become odd only. That's why these numbers are 1, 3, 5, 7 like this. I hope these two conditions you have followed. When the two waves are said to be interfere constructively if delta is equal to n lambda. When they are said to interfere destructively if delta is equal to 2n plus 1 times lambda by 2. And in constructive interference, the intensity of resultant wave is going to be equal to 4 times of incident wave intensity. And in case of the destructive interference, the resultant wave intensity is going to be equal to 0. So for constructive interference, you are going to have the brightness, and for destructive interference, you are going to have the darkness here. Okay. So this how this is can be proved with the help of the mathematics that we have to see here now. Right. I need this space to write here. So I am going to write for first diagram here. I am going to write for first diagram. So I am going to write this side here. See here, this much space is enough for me. So see here, I will manage this space to write here. So I am explaining first what is here. S1P is equal to S2P. What I am going to prove? I am going to prove that intensity of incident light is equal to 4 times of I naught. Okay, now how many waves we have here? 2 waves. The first wave is what? Y1. So Y1 I will use by yellow color only. Your first wave is what? Y1 is equal to A cos omega t. We know the equation of wave in PUC first year. Y2 is equal to again A cos of omega t, and these are the two incident waves. So intensity of incident wave I naught is directly proportional to A square, because what is the amplitude of first wave? A. What is the amplitude of next wave? Again A. So incident wave intensity is directly proportional to square of A. So therefore I can write I naught is equal to K into A square, where K is the constant of proportionality. Okay, now these two waves are meeting at this point P. So by superposition principle, what I can do here, the resultant wave intensity is Y is equal to Y1 plus Y2. Okay, so this is equal to, what is Y1 here? It is A cos of omega t, plus what is Y2 here? Again it is A cos of omega t. So this is equal to 2 times of A cos omega t. So is it your resultant wave? And this equation number 1 is incident wave, equation number 2 also incident wave, and equation number 3 is your resultant wave. And what is the amplitude of the resultant wave? 2A. And we know the intensity of the wave is directly proportional to square of the amplitude. So this implies I is equal to K into 2 square 4 into A square as it is. So this implies I is equal to 4 times of Ka square, yes or no? And what is Ka square from equation this number 1 and 2? You can see here, what is K into A square? So this implies I is equal to 4 times of K into A square. What is K into A square? It is intensity of the incident light. So this is your formula done. That only I was trying to prove that. This only. Yes sir, I proved or not this. Okay. So what is the intensity of resultant wave for constructive interference? It is 4 times of incident wave intensity. I proved here. I is equal to 4 times of I naught. Very easy here. For 5 marks it is almost a lottery question. You may ask here why not sine I to take here. You can take sine, no problem. But as per NCERT textbook, I have taken the cosine wave for my theory. So you also go for the same here. Cos function is easy to handle here in case of this wave interference of light here. Okay, this I have proved here. So first one I have proved what the intensity of incident light is 4 times of I naught. Now second one, S1Q is less than S2Q. Again this is the same condition for the constructive interference. Now I am going to explain the second one. What is second one here? S1Q is less than S2Q. Okay, now see, S1Q wave is what? Y1 equal to A cos of omega t. Now what is S2Q wave? S2Q wave is what? Y2 equal to A cos of omega t minus this. This wave is extra here. So what I can write here? I will write my expression here. Here I will write here. We know this I naught is equal to what here? K into A square. Now this is cos of omega t minus 2 pi. Why in the first term? Why in the first calculation of S1P equal to S2P 2 pi was not there? Because the two waves was having the path difference of 0 here. So A cos omega t, this is also A cos omega t only. But now Y1 is A cos of omega t, but Y2 is what? A cos of omega t only minus this extra portion. So this extra portion is how much? Lambda, and we know the lambda is equal to the angle of 2 pi. You can go to my previous introduction part of this class only. Whenever I will write the wavelength, it is equal to the path angle of, or it is phase difference of 2 pi. Angle of 2 pi is corresponding to length of lambda, or wavelength of lambda is corresponds to angle of 2 pi. So this path is extra, so I have written here minus, and this implies that this Y2 is equal to A cos of theta minus 360 is again cos of theta. So again this y2 is equal to what? A cos of omega t. Even this 2 pi is subtracted here, nothing is happened to the wave equation, still it is y2 is equal to a cos of omega t only. So this is your same equation number 1, this is the same equation number 2, and I can go for the same write up here. So again, what is the intensity of light? We have proved the intensity of the resultant wave is 4 times of the incident wave intensity. I hope this you have understood. Right, again if you have the question why minus 2 pi, you can go for this diagram here. This is the extra portion here, this extra portion length is how much? Lambda, and for this lambda what is the corresponding angle? 2 pi. This is the extra portion in second wave. So in second wave I have subtracted the extra portion, and what is the extra portion here? It is 2 pi. Okay, now we will move to the last section. It is constructive interference I have proved. Now I have to go for this same proof you have to copy here. I will again once again I will not write here. Okay, now the third proof for the destructive interference. What is the third proof here? For S1R greater than S2R. Now interestingly we can see this, only this I will change, remaining things we will see, otherwise this part again I will write here. So now here what I can see, first wave, this much portion is extra. My question is how much angle here? Lambda by 2. We know lambda is equal to 2 pi. Then what is lambda by 2 equal to? What is lambda by 2 equal to? Is it equal to pi now? So what is the first wave here? Y1 is equal to, I will write like this, Y1 is equal to a cos of omega t. Extra portion is what? Lambda by 2, and lambda by 2 means what? Pi. So it is omega t minus pi. Okay, now this implies that y1 is equal to minus of a cos of omega t, because cos of theta minus 360 is minus of cos theta, right? Same thing I have represented in your notes also. Here we can see this y1 is equal to a cos of omega t minus pi, and cos of theta minus 360 is minus of cos theta. So this is my equation number 1, and equation number 2 is as it is, no change in that. So y2 is equal to what here? A cos of omega t. This is equation number 2. Again the question may come here, why this is minus pi here? So for this, if you ask me, your answer is this here, because this part difference of lambda by 2 is equal to angle of how much here? Pi. So this is the pi x section is extra, it is minus sign equation number 1, this plus 2. So here everything is going to become 0 here, because this y1 is minus here, and minus a cos omega t plus a cos omega t. So this answer is going to be equal to 0. And what is the intensity of the resultant wave? It is equal to now 0. The resultant wave vanishes. Resultant wave vanishes because it is, we are having the destructive interference here, because the crest of one wave is going to fall on the trough of another wave, and crest trough addition is equal to 0. Trough addition is equal to maximum, crest addition also equal to maximum here. Okay, so what is the condition today? This is only the today's class now. So in this today's class we have seen that in case of constructive interference, the intensity of light is going to be equal to 4 times the incident wave intensity. How we have proved that? And in the destructive interference, the intensity of the resultant light is equal to 0. For constructive interference, the path difference is equal to delta is equal to n lambda, and for destructive interference, the path difference is equal to delta is equal to odd multiple of lambda by 2 here. Okay, so generally we can write the expression here. So I have got the title here, condition for constructive and destructive interference. Once again I am going to draw here, condition for constructive and destructive interference. Condition for constructive and destructive interference. Already I wrote, once again I am going to copy here. So it is destructive interference. So generally I will prove here, equation number 1 is, one wave is y1 is equal to a cos of omega t, and next one equation is y2 is equal to a cos of omega t plus phi. So for the today's first concept, S1p is equal to S2p. For that phi was equal to 0. For next case phi was equal to 2 pi, and for the third case phi was equal to pi here, right? Still we have this here, we can see here, right? So by superposition principle, this is your equation number 1, this is equation number 2. This is generally I am proving what the part I have written now. Y1 is equal to a cos omega t, y2 is equal to a cos of omega t plus phi. It is applicable generally to all the diagrams here. My 3 diagrams of today's class also can be explained by this here. So by superposition principle, what I can write here, this intensity or the resultant wave amplitude, resultant wave is y is equal to y1 plus y2. So what is y1 here? A I can take common, in bracket what is there? It is cos of omega t plus, this is cos of omega t plus phi. Right, this is the expression for y. Now this implies this y is equal to, I have to apply the formula now. I will copy as it is now because I don't want to waste my time in writing this here. It is 2a times of cos of, how it comes I will tell, it is cos of minus phi by 2 into cos of omega t plus phi by 2. If you ask this step me how, then I will tell you go by your mathematics here. Right, what is this cos of c plus cos of d? Cos of, or I will take cos of a plus cos of d here. Suppose this is the a term I am taking, right? This is, suppose I am taking this a term and this I am taking as b term. So what is cos a plus cos b? Cos a plus cos b. So it is 2 times of, so that's why 2 term came, 2 times of cos of a plus b by 2 into cos of a minus b by 2. The moment I do a plus b by 2, we are going to have something different here, right? So what is happening here? The cos of a plus b by 2. So what is a here? Omega t plus this omega t plus phi divided by 2. So what will happen here? 2 times of omega t by 2 plus phi by 2, 2 gets cancel. So what is for addition you are going to get? Omega t plus phi by 2. How you got for addition here? For subtraction, a minus b, omega t minus phi, omega t cancel, and this is by 2 here. So what you are getting here? Minus phi by 2 for subtraction term. Yes, so it is 2 times of cos of a minus b by 2. A minus b by 2 means what? Minus of phi by 2. And a plus b by 2 means what? Omega t plus phi by 2. How it came? I proved here. That's why I told you go by mathematics here, CD formula sometimes. Cos a plus cos b is equal to 2 times of cos of a plus b by 2 into cos of a minus b by 2. Same thing I have applied here. Now we can see here, therefore this y is equal to r into cos of omega t plus phi by 2, because this box term is a number, it is not a wave. I can put the value of phi equal to 0 and cos 0 is equal to 1. So this is a number, so this number is nothing but the amplitude of the resultant wave, and this is the cos nature now. So here we can write here this intensity of this wave, what is the amplitude here, or you can write a capital A. This capital A is equal to amplitude of the given wave, which is equal to 2a times of cos of minus phi by 2, and the intensity of this resultant wave is directly proportional to a square. So this implies I is equal to k into a square, means what? 4a square into cos square phi by 2. So this implies I is equal to, we know this k into a square means what? It is equal to I naught now. So 4 as it is into I naught into what? Cos square phi by 2. This is your main expression here. I is equal to 4 times of I naught into cos square phi by 2 here. I'll write once again. I is equal to I naught. I is equal to 4 times of I naught into cos square phi by 2. Now this phi value will decide whether this intensity is going to be 0 or this intensity is going to be equal to maximum. This phi value will decide this, right? So what are the values of phi available? This is the first one, this is the next one. So I will take the help of your notes. So what is this? I completed the today's class. What is the value of phi for the available here? For the first case it is 0, 2 pi, 4 pi, so on up to, and this is pi, 3 pi, 5 pi, so on up to. It is plus or minus. here also plus or minus. Okay, now you can try this. Keep cos 0, phi equal to 0. What is cos 0? 1. So this is I am writing for constructive interference, and this I am writing for destructive interference, because if I keep phi equal to 0, then only you will have this intensity equal to 4 times of I naught for constructive interference. Even if I keep this phi value as 2 pi, 2 cancels, and cos phi is minus 1 square, again 1 only. So these intensities are maximum for constructive interference for phase difference equal to 0, 2 pi, 4 pi, so on up to. The moment I keep the phi value equal to pi here, see, so pi by 2, so cos of pi by 2, cos of 90 is how much here? 0, and cos 90 is 0 means everything is 0 here. Cos of this 3 pi by 2 again 0. So this is your conditions here. So you will have the constructive interference for, I hope this concept you have understood. So you will have, I will write here, you will have the constructive interference for phi equal to 0, 2 pi, 4 pi, 6 pi, like this here, and you will have the destructive interference for this phi is equal to pi, 3 pi, 5 pi, so on up to, 5 pi, so on up to. But we know this lambda is equal to 2 pi. So what can I write here? Phi equal to 0. Can I write this pi is equal to lambda by 2? So this is 0 here, 2 times of pi means what? Lambda by 2. 4 times of lambda by 2. 6 times lambda by 2. This side phi is equal to pi. What is pi is equal to now? Lambda by 2. This is 3 times of lambda by 2. This is 5 times of lambda by 2. Is it same thing I am going to have here? So this is equal to phi equal to 0, lambda, 2 lambda, 3 lambda, so on up to. This phi is equal to lambda by 2. Same, no change in this here. So for this what I can write here? This phase difference will become now path difference. So is it a path difference is equal to, again condition is n lambda, for n is equal to what? 0, 1, 2, 3, 4, so on up to, and same thing I wrote here also. For this case what I can write here? This phase difference is equal to path difference. Phase difference means angle and path difference means length. So this is equal to what? 2n plus 1 lambda by 2 for n values, where n values equal to 0, 1, 2, 3, 4, so on up to. This is the condition for destructive interference, and these are the conditions for the constructive interference. Okay, so this is your today's class now. In the today's class we have completed the interference of light concept in detail. In the tomorrow's class tomorrow means in the next class we are going to have one very important derivation of 5 marks. Maximum time that derivation is asked in examination, and if that derivation is not asked, then the problem related to that derivation they are asked in the annual examination. So next class is very important, and for the next class, this today's class is the basic class here. Okay, so with this we will conclude the today's class here. Watch the video regularly and study properly. Thank you.